What's up, you guys? Welcome back to the channel. In today's video, we are going to take a look at how to make this complete playable two-person chess game in Python using the PyGame module. We're going to do it line by line together from scratch. So I'm really excited to bring you guys this project in particular. It's one that I've had several requests for in the comments section of the past videos when I kind of request, what do you want to see in a future video? Several people have said a playable chess game would be cool. So that's what we're doing here. And I want to point out some of the features and overall project structure before we dive into it, because this may be a project where you want to take advantage of the chapters underneath the video. So obviously with all these big projects, I try to put the GitHub link to the code and all of the assets in the description section of this video. And so that applies here as well. And that's going to be especially useful for you guys because these images of the chess pieces, they're not drawn from scratch within Python, like a bunch of lines and rectangles and circles. That would take forever. So what I did is I got the images, I made them for you, and I put them all in an assets folder, which is on the GitHub link. And in the beginning of the project, as you'll see, we load them all in. And so this section of code is going to be a little bit monotonous when we get there. So my recommendation would be perhaps get the GitHub so that you at least have these images and assets. And then you'll see when we get to this portion of the tutorial, I'm going to talk you through what this section of code does and why we need to set it up this way. But then even I'm going to just import this list of loading in the images. So I would kind of recommend the same to you guys. I will cover it in enough detail that if you want to do it from scratch, you totally can. But if you don't already have a set of chess pieces, you're going to need to go to the GitHub and get the images anyways. So I recommend starting from that because these pieces are probably the only real tedious part of the entire project. Other than that, it moves pretty quick. Just to highlight a few of the cool features here. When you select any piece in the game, our program is going to calculate the valid moves that piece can take, and it's going to display them on the screen for you. And so this is for every single piece. We came up with an algorithm to check the valid moves for a pawn, a king, a rook, a knight, a bishop, a queen. We're going to do all of it together, and that's a really cool bit of code. And then additionally, when the king goes into check for either player, we're going to flash it and highlight it to make sure the player knows that they're in check. And then we also, similar to regular chess, we give players the opportunity to forfeit rather than play out a total defeat. And we also give the ability to restart. We also keep track of captured pieces on the side of the board, so you can kind of visually get an idea for who has an advantage, which is a fun little feature that sort of replicates real chess. And so total, I'm really stoked to do this project together. Before we dive into the tutorial, consider leaving a like on the video, subscribing to the channel. It really, really helps me out, and it helps me do these big projects like this for you guys. And also, huge shout out to my Patreon supporters. I really appreciate you guys. You're helping the growth of the channel so much as well. Now, without any further ado, let's get right into the tutorial. All right, so for part one of this tutorial, we're going to start by importing PyGame. And if you've ever made a PyGame game before, you know that you kind of have to start with importing it. And if you don't have the module already, just run pip and that'll get it installed for you. And then do this pygame.init, and that's just initializing the package. You'll basically have access to everything in it by doing that. And then pick a width and a height variable for your version of the game. So I'm going to do, oh my goodness, I'm going to spell it correctly, but I'm going to do a width of 1000 and a height of 900. And then you use those in this screen equals pygame.display.setMode tag like that. And then you just want it to be width, comma, height like that, okay? And so the next thing is we want to set up a font. And pygame.font.font like this, where the second .font is a capital F. Most of your computers, if you're running Windows for sure, are going to have this free sans bold.ttf built in already, so you don't have to grab a font file. But you can, if you want a more stylish font, you can definitely do that. And then I'm also going to make a big font. So this is something where you can play around with it when we actually get to the font portion of the game. But basically, if you have text that you want different sizes, you need different fonts for them, or you need to make your font size a variable. They're both valid ways of doing it. Because I'm really just going to need some big font for instructions and then little font for other things, I'll just make 2 here in the beginning. Free sans bold.ttf. And to make it bigger, we'll go font size 50. And then you need a timer, pygame.time.clock, like this. Okay, and that's what's going to control the speed at which your game updates and the number of frames per second here that your game kind of runs at, and we'll do 60 per second. And now we're going to come back and we're going to add a lot of game variables and images, because what we're doing in this chapter 1 here is the setup. But now let's take a look at just setting up the main game loop, as I always call it. So here in the beginning, we're going to make a variable and call it run and set it equal to true. And then we're just going to say while run, we're going to do all of these things that we're about to type in. So this is our main game loop, okay? So while run, first thing to do is just that timer we made, dot tick at our frame rate, so our FPS. And then second thing is going to be just screen.fill, whatever color we want the background to be. So I'm going to go with dark gray because I kind of like that. Feel free to make obviously your background any color you want. But then the next thing we need to do to just set up the initial PyGame board is start our event handling. And to do that, we'll do this if event.type. Sorry, the first line needs to be for event in PyGame.event.get, like that. So this is getting everything that goes on in your computer, keyboard, mouse input, all that stuff happens here. So this is event handling to call it. I'm trying to do more comments. I know you guys like that. Let me try to move this mic a little closer too. Hopefully that'll improve the audio quality a bit. But okay, so for event in PyGame.event.get, then we just want to say if event.type. So the type event that just happened is equal to PyGame.quit, like this. And so that's the pre-built PyGame instruction to check and see if the little red X in the top of your game window was clicked. And if it is, then we will just set run equal to false, and then we'll come down below all that and we'll say pygame.display.flip. That'll kind of throw everything onto the screen. And then out here, we'll just say pygame.quit. So this is what we want to have happen if we press the pygame.quit button, and that will actually end our program, okay? So if I were to boot just what we have here up, we should get our basic outline of the game board. Yeah, so you can see it's pygame.window. It doesn't have a title. So actually one more quick and easy thing we'll do here is where we did set display here for the screen, we'll also do pygame.display.set caption, and we will just say 2-player pygame chess, okay, just like that. So now if we boot it up, we have 2-player PyGame chess, all right, which is great. But now, just as a warning, we have to do a lot of setup stuff that you'll be really glad later on in the project we've already done, but it's a little bit tedious, so I'm going to try to go as quick as I can. Obviously, all of the code and assets are available in a GitHub, so if you get lost or you need to kind of understand what's going on, then stick around. I'm going to do every line by line, but also the section I'm about to do is a little bit of rinse and repeat, copy paste. So if you wanted to just copy this section from the GitHub, that's totally reasonable too. So basically now we're going to start going through all of the pieces and their locations and the images, okay? So first we'll make a list for the white pieces, and this will keep track of what pieces are on the board and where they are. So obviously a chessboard, on a chessboard it goes rook, knight, bishop, king, queen, another bishop, another knight, and and another rook. Okay, that's the back line. And then you've got, again, same number of pieces, but a whole row of just pawn. Okay, so let me go ahead and just copy this one and give us 8 of them total. So 1, 2, 3, 4, 5, 6, 7, 8, and then get rid of the comma. So that should give us our full board. 8 kind of masterpieces, and then 8 pawns. All right. And now let's go ahead and just make a copy of that whole list to be our black pieces. And this is, again, I'm going to use the same order, even though obviously the order of back row, front row has switched. But that's okay, because this is just a list of what pieces are on the board. Now we're going to make kind of associated lists of those same pieces, but what their locations are. All right, and the way I'm looking at this grid is going to be sort of the way PyGame handles coordinates. So the top left is 0, 0. The bottom right is essentially 7, 7. So as you go across the squares of your chessboard, you have 0, 1, 2, 3, 4, 5, 6, 7. And as you go down, 0, 1, 2, 3, 4, 5, 6, 7. Okay? So the positions that those pieces that we just defined go, that first rook goes in the top left corner. So it goes in position 0, 0. That knight goes in 1, 0. And then all these pieces go across that top row, 2, 0, 3, 0. I'm having some trouble typing. 3, 0, 4, 0, 5, 0, which I didn't put in parentheses. I am just being really inconsistent. 5, 0, 6, 0, and finally 7, 0. So that gives us all the positions for the back row. And then the front row, I'm just going to make my life a little bit easier here and copy all of these and change their 0 y coordinate to a 1, because obviously the pawns have the same columns. They just are all 1 down from the row above it. Okay, so it's not going to help us out a ton to copy the white locations list for the black locations, but it will help us. It's a little bit easier than starting from scratch on a list. So now the back row, the rook, knight, bishop, all that, they're in row 7. Because remember, there's 8 by 8 grid, so I don't mean to confuse anybody, but in programming, you really start counting from 0. That's always kind of the first bit available to you. So we're always going to kind of start counting from 0. And if we have 8 of something, we're going to stop at 7. Okay, so then these pawns will all be in row 6. So, all right, so this gives us a good list of all the white pieces and all of the black pieces. And what we'll do as well is just captured pieces underscore white. And this is going to be empty in the beginning, but again, it's going to be really nice when we're putting the functional code in to already have these lists made. You're going to have somewhere where you keep track of what pieces are captured if you want kind of a nice chessboard feel of like having the discarded pieces off to the side, which is something I think will look pretty cool. All right, and then we're going to keep track of kind of the phases of each turn with this variable turn step. So basically, if you think of every turn, there's 4 pieces. There's going to be basically 0, which is white's turn, no selection. And then there's going to be 1, which is white's turn, piece selected. And then there's going to be 2, which will be black turn, no selection. And then 3 will be black turn, piece selected. Okay, so we're going to use this variable. I guess I'll try to get that down just so it stops throwing that. This is going to be a variable that keeps track of which one of those 4 phases we're in. We're going to use this a lot to know what player is currently active and what valid moves are currently on the board. Okay, and then we're going to make a variable for whatever piece is actively selected. I'm just going to make it 100 because that's large enough that it's not an actual index. So like when you pick a piece, we'll keep track of what index in that list it is by storing it in this selection variable. And when no piece is selected, we'll make it 100, or you could make it 1,000 or 10,000. We'll just make it a large value that won't be on the board, basically. And then let's make a list of valid moves. So once we select a piece, we're going to check and see all of the valid places that those pieces can move. We'll put that in a list we'll call valid moves. All right, and now this, guys, I do not want to discourage you at all from just getting this from the GitHub. We have to load in game piece images, and this is going to take a long time, okay? So in total, we have to load in queen, king, rook, bishop, knight, and pawn, and we have to do that kind of times 2 because we need the white pieces and the black pieces. So in the assets folder that, again, is also going to be with my GitHub, there are bishops, knights, pawns, queens, kings, rooks for both white and black. And you can use these images. You can get them for free off the GitHub. So I also suggest when you're there, grab the code where we load in these game pieces. What I'm going to do is I'm going to load in, I'm going to do one manually, and then I'm going to copy it from the list because it would just be so much time on this video, you guys. So I'm going to talk through the black queen, okay? That's going to be the first piece that we're going to load in. And to do that, it's this pygame.image.load. And then you need to point it at where it's loading it from. So in my folder structure, it's assets, images, and then I called it black space queen. So I just gave them like a descriptive 2-word name of the piece, but I didn't put underscores in there. But so we're just basically loading the image in. And then what I'm going to do, because I kind of gave it a variable name that I want to keep using, I'm going to do this pygame.image.scale. So they're all kind of big, and I want to be able to have it down to the size that I need to use for my individual squares. So I'm going to scale them down to 80/80. As we'll see when we draw the board, this is dependent on how big you make your tiles. So if you want to make them bigger pieces, you need a bigger board. If you want them smaller than 80/80, you just need a smaller board, okay? So we're gonna have this as our piece, and you could also put this entire pygame.image.load right here, and you can do it all inside of one line. It's just they get kind of long, and it's a little bit, in my opinion, more unclear what's going on. But if that works for you, feel free to do that. And now what I'm going to do is I'm going to make a second one, because again, when we draw the pieces off to the side in our discard area, we need a smaller version of it that looks a little better off to the side, because these full 80/80 ones look really big off to the side. So I'm going to do that. I'm going to have a small version of it and a large version of it in these 80/80 squares, because even though the actual image itself, the Black Queen image, is not a square at all, you can actually see in the corner, hopefully you can see, the image that I made it on was a 1080 pixel PNG file. So to keep its proportions correct, you just need the same width and height. It's gonna look good. There's no background on the image, so it'll look good when it's loaded in. Now, that is what we're going to do for every single image in here. So like I said, I'm not going to go through all of it with you. I have them all ready to go. But so you need all of your pieces. If you're going to do it without images, then you need to come up with whatever shape that you're drawing, like a circle or a rectangle, then you'd have to do that here. But so I just went and I grabbed all of the images for all of the pieces, black and white pieces, and I copied them in here. One thing I'm going to touch on, because it's a little different than all the rest, I made the pawns 65/65 in my version because it just looks better. The pawns are supposed to be smaller than all the other pieces, so feel free to play around with this scaling later if you want. But again, you're going to be super thankful we did this at the beginning and we didn't take a pause an hour deep into this tutorial to do that, okay? Now, what we're going to do is make a few lists, okay? So we're going to make a list of the white images, and we're going to put in the variables for the white pawn, the white queen, the white king, the white knight, and the white rook, and the white bishop, okay? So we're going to make this list because now when we want to draw our pieces on the board, we can just check what piece it is based on its name, and we can look up the associated image with it. So then what we'll also do is we'll do small white images because we'll do the same kind of thing when we draw the discards off to the side. But so now you need to have the underscore small in the list. So white queen, small, white king, small, white knight, small, let's go, enter, white rook, small, and white bishop, small. Okay, so hopefully this makes sense to you. We are going to do the same thing for the black images right up front, small white images, small black images, and then regular black images. So everywhere in here, we're just going to change white to black. Be careful that you get all of them because you will notice when you boot your game up, if you missed one, you'll have like white bishops on the black side and vice versa. So just make sure you're a little careful about getting them all changed. But this is a really nice step. And there, so it hasn't taken a ton of time, and we have all these operational lists that we're going to be able to use pretty frequently. Now what we need to do is just create a list that is actually going to be strings that's going to basically say what this says, okay? This order that we picked for our pieces, we need something to say, okay, if I have a pawn, then it needs to be able to have the same index as the image for it, right? So just thinking back to our original list, I know it's a little while ago, but our list of the white pieces and black pieces, they have a name that is a string, but because there's 16 pieces, there's more than just one of each type. Their index does not align necessarily with their image. So what we can do is we can take their name and we can say, all right, if a piece has the name knight, it has an index in piece list equal to 0, 1, 2, 3, which means it has an image index of 0, 1, 2, 3. Okay, so this is going to be really important when we draw the pieces on the board. We need to be able to associate the piece's name to its specific index in the image list. All right, so that is an important list to have right there. And then I think the only other thing that we'll want to do down here is some check variables, which we'll put in later when we actually get to checking. So like check variables and maybe like a flashing counter. Okay, so I know this is a lot of code that we haven't gotten to see take shape yet. It's a lot of setup, it's a lot of initial stuff, and so far, just as a reminder, when we boot it up, we just have this gray rectangle, but I promise you guys this project is about to start flying because of all the setup we just did. All right, so that is the basic setup, the establishing our variables, establishing our game pieces. Now let's get into some of the fun stuff like drawing the board and drawing the pieces on the screen. All right, so let's come under where we do our screen.fill and let's make a new function called drawBoard, okay? And let's go ahead and put that kind of after all of our setup stuff, but definitely before this game loop. And let's do draw main game board in this loop, okay? And so we'll call this, you have to do def to call a new function, and then draw underscore board like that. And it's not gonna be all that difficult. In total, we just need to go through and we need to make sure that we have kind of boxes prepared for every square. And a traditional chessboard kind of has every other square alternating in pattern. So we'll do something similar here. We'll say for I in range, and then we'll say 32, because you probably know 8 by 8 is the total grid, so there's 64 total rectangles on the board, but we can just get away with every other rectangle being our background color of dark gray. So rather than draw 64 unique rectangles, we can just take advantage of our dark gray background and make like light gray squares, as long as we handle the math to kind of make sure that they use the unique pattern. So let's take a look at how we achieve that, okay? The column that we're currently in is going to be equal to I remainder 4. Okay, so that that percentage sign is the modulo operator. It checks what the remainder is when you divide by something. And then the row is going to be I floor divided by 4. Okay, so this is always going to round down to the nearest whole integer. All right, so think about it this way. As I is 0, 1, 2, and 3, so your first 4 squares, row is going to be 0 for all of those because it's rounding down. But your column is going to go 0, 1, 2, 3. And then you're going to be, the next 4, we're going to be 4, 5, 6, and 7. Now row is going to be 1, and again column is going to go 0, 1, 2, 3. Okay, so this is how we can get column and row, but we have to make sure that we offset them every other row. Okay, so we'll say if row modulo 2 is equal to 0. And this is just an easy way of checking if the remainder of our row division is 2. It's an easy way of checking if something is even, okay? Then we can do pygame.draw.rect, and we will put this rectangle on the screen, and we will make it light gray. Have a lot of trouble with the word light, apparently. And then for its x position, let's put it at 600 minus the column, so whatever column it's currently in, times 200, okay? And so to talk about why that's going to be the position that we do it in, remember, I make the total screen 1000 wide, but I want a little bit of space off to the right where I can draw the defeated pieces. So what this is going to give me when my column is equal to 0, this is going to give me an x starting position of 600. When my column is equal to 1, it's going to give me an x starting position of 400. When it's 2, it'll give me a starting position of 200. And when it's 3, it'll give me a starting position of 0. So all the way over on the left, okay? And then we're just going to go down 100 pixels at a time per each row. And I'm going to make each square 100 by 100. Okay, so we have this useful if row is even, then we'll put them there. What we need to do is put an else condition, and now we need to offset them. So in the same vertical spots, but we need to offset them horizontally. So to do that, we're just going to do 700 minus the column times 200. And now this will push them all 100 pixels to the right of where they were previously. Okay, so just booting this up, we should see a checkerboard pattern, okay? And we haven't drawn outlines yet, and we haven't drawn rectangles or anything to define the space, but you can see this really easy way by just doing some simple math and being able to think about it two-dimensionally. We've created a simple for loop that draws our entire checkerboard. So I think that's really cool. Now the next thing to do is going to be draw some of the borders for the overall shape of the top, and then the bottom, which will be like the instruction area, and then the right, which will be like the deceased piece area. All right, so let's just start with pygame.draw.rect, and we'll draw some of these outline rectangles. So we'll put them on the screen, and we'll make this one just regular gray, right? So we have light gray and we have dark gray for our squares. Let's just make a regular gray box around the entire game board area. So X starting position 0, Y starting position 800, so it'll be at the bottom of the game board, and then we'll make it the full width of the board, or the full width of our screen. And then we'll make it 100 tall, 100 tall. So this is going to be the bottom menu outline. And then let's go ahead and make another rectangle that will be kind of in the same spot, but this time rather than a solid rectangle, let's make a border for it that is gold. So just to show you this two-toned effect, I'll boot it up. Now we have a light, you can probably tell it's not the exact same gray as either of the two squares of our game board, and it has this gold banner around it. It's just a useful way of showing that we have kind of a separate thing going on the bottom. And now let's just go ahead and draw a gold rectangle on the right. And so for this one, we'll actually start it at X position 800 and Y position 0. And then we will make it only 200 wide because that's all we need to get to the right edge of the screen. And then we'll do the full height of the screen, okay? So now we have kind of this overlapping two gold rectangles, right? We have the bottom where we'll put the instruction text, like white, it's your turn, select a piece, and then black, it's your turn, select a piece. And then over here on the right, we'll draw the deceased pieces, okay? So that's kind of my thinking of what we'll use these zones for. But we did it with just a few rectangles, which is nice. Now, what we want to do as well is put some status text onto the screen to say, like I just said, to say what stage of the game we're in. And so if you think back to what we said the four phases were going to be, it's white's turn to make a pick, and then it's white's turn to move that piece, and then it's black's turn to pick a piece, and then it's black's turn to move that piece. So what we'll say are that the four pieces of status text we could have are, first, it'll be white, select a piece to move, like that, okay? And then the second one will be white, select a destination, like that, okay? And then we will kind of just copy these and change white to black. And then those are going to be all four of the instructions. Also, quick disclaimer, sorry if the audio has changed throughout this video. I'm trying to get the mic in a good position where it sounds good, but it's not in the way of me typing. And I don't know why my setup got all moved around in the last few weeks, so just bear with me. Trying to give you guys good tutorials here. So for the status text, let's go ahead and say that we're going to do this in our big font. So we're going to do big font dot render, and here's where we say the text, and it's going to be a formatted string of basically, actually, we don't even have to really format the string. We just say it's status text of whatever turn step we're actively at. That's the text that we want on the screen. But when you render a font in PyGame, you need to give it 3 arguments. So anti-alias, put as true. It's just like a smoothing factor. And then we're going to make this text black. And then now we're outside of the font.render. So for font.render, it was you give it the text, you give it an anti-alias argument, and then you give it the color of your text. Okay, so that's it for font.render. But then for screen.blit, you give it what you want to draw onto the screen. So that's the text. And then you give it an X and Y position. And for status text, we'll put it right in that bottom area that we just defined for status text, okay? So let's go ahead and take a look. It should just say white, select a piece to move. Yeah, so that looks pretty good, and as we move through our turn, that's going to update and tell us what to do with our next turn and our next turn. So the last thing I want to do, just because it's going to look a lot nicer for our board, is to go ahead and just draw horizontal and vertical lines separating the boxes out. Just make that checkerboard really pop, okay? So to do that, we'll do pygame.draw.line, and we'll put it on the screen, and we will make them all black. And then for X and Y starting position for our horizontal lines, we'll do 100 times I as our starting Y position, and then we will go to position 800, but still 100 times I for our end Y position. So this means every line horizontally will go from X equals 0 to X equals 800 at 100 times I. So for the first one, it'll be 0. The last one it runs will be I equals 8, and now draw a line at 800, okay? And let's make it thickness 2, just so it's a little easier to see, but doesn't totally take up the screen. Those are our horizontal lines. Now let's go ahead and take a look at how to modify that for our vertical lines. And if the last thing that I did made sense to you, then hopefully this one does too. It's just kind of the same deal where the direction of the line that we're drawing is the variable you want to change. So these are vertical lines, and so they need to change in the Y direction from 0 to 800, and in the X direction they don't need to change at all. So now if we boot that up, hopefully that is it for draw board. Yeah, you can see we just got this. I really like the way that looks. If you liked it more without those lines, just get rid of those lines of code. But I really like having this clearly defined checkerboard space, okay? So that is going to be it for draw the board. The next thing I want to do is draw the pieces, and I want to do that in its own function. So I'm going to come down just below where we said draw board, and I'm going to say draw pieces, okay? So let's go ahead and make a new function, and we will just say draw pieces onto board. And it's actually very important that you do this after you draw the board. Otherwise, your board squares could overwrite your pieces squares, which is not what you want, all right? So let's go to the draw pieces function, and let's just start with the white pieces. It really doesn't matter. This is all going to happen at the same time, but for I in range, length of our list of white pieces. And this is important. We can't just, we can't just say for I in range 16 because we're not going to have 16 pieces the whole time. So it needs to be smart enough to just check for however many pieces are in the white pieces list. Then we need to say, okay, our index is going to be equal to that piece list that we made dot index of whatever the white pieces at I is. Okay, so I'm going to pause really quickly to talk about what we're grabbing here. The white pieces list is that full list of 2 rooks, 2 bishops, 2 kings, the king and the queen, and then 8 pawns. So this is the full list of white pieces. But again, to know what image we should draw onto the screen, we have to get an index value that will tell us what of these images we can actually use. So that means we need to get this index. So that's why piece list, we need to get from the piece list whatever the index of the piece that we're currently looking at is. Okay, so that's what this line is doing. Now we can just check if white pieces at I is equal to a pawn, let's say, equal to pawn, like so. Then we can do screen.blit. Actually, what am I doing? I don't think we need something separate. Oh, we do have to do a separate one for the pawns because they're different sizes. So all the other ones you'll see we can use just something generic. Screen.blit. And then this will just say the white pawn. Doesn't matter. Okay, so the image for a pawn is going to be the white pawn, and the white locations at index 0 or index I and then 0 is going to tell us the x coordinate times 100. And then because the pawns are small, they have to have an offset so that they sit in the middle of the screen. And this is a little bit of guess and check. Again, if you change the dimensions of your game to not be 1900, then you have to change these offset factors as well. But to get a pawn to sit in the middle of the screen, you need to bump it about 22 to the right from just being at the from just being at the left edge of each square. And then white locations at I, and then 1 is going to give us each y coordinate, and that's going to be times 100. And again, for the pawns, we need to offset them by 30. So I know that's a little bit tedious because we had to do a separate one just for the pawns, but the really nice part is we can kind of steal this, okay, and we can say else. Let's make sure we got the indentation right. Else, now what we're going to screen.blit, we don't have to say white pawn specifically. We can just say white images at index. Okay, and we could have actually said this here as well because our index checking should still work that it's the pawn. But this just makes it super clear. This is just for pawns. All right, but so we still want a like 100, 100, but now these offsets should not be 22 and 30. They should be just 10 and 10 because all our other images are quite a bit larger, okay? So that should give us every image in its proper location drawn onto the screen. And now let's do the same thing for the black pieces. So, and we're just gonna go through everywhere that we see. We're checking for anything white, and we will do the same check now for anything black. So black locations instead, and then black pawn, black images, black. There we go. And there we go. Okay, so just with this stuff, hopefully we should be able to see, let's see what it says. I have an error, so I'm sure it'll tell me what it is. Let's take a look. Console. Oh, problems. There we go. Unresolved reference, draw pieces. Well, yeah, I called it draw pieces. What'd I call this? Oh, I called it define pieces. Nice. Okay, so I just gave the function the wrong title. Let's go ahead and boot it up. And there you go. I'm super happy with this. We have pieces in locations that are correct. I double checked against a real chessboard just to make sure I wasn't getting it wrong. But all the pieces are drawn in location. It looks really good. Let's go ahead and handle just one extra thing here, and let's actually highlight whatever piece is selected, okay? So obviously we're not actively selecting stuff yet, but when we are, we want to make it clear to the player that they have a piece selected and what piece that is. So to do that, let's go ahead and say if turn step is less than 2, because that means that it's the white player's turn. If selection is equal to I, okay? And so we know that it won't because it's 100 when we boot it up and we haven't selected a piece yet. But eventually you're going to click on a piece. We're going to capture what index from the list that piece is. And if that's the piece that's actively selected in our draw pieces function, then we're just going to draw a rectangle. So pygame.draw.rect, and we'll just draw it around the whole square of the piece that you have selected. That should make it just super clear what piece you have selected. Okay, and so the place we're going to draw it at is just I0 for X starting position times 100. And then for this one, we'll just do +1 to kind of scooch it off of the black lines that we drew. And then we'll say the Y coordinate will be white locations I and 1 times 100, and again just a +1. And now for width and height, we'll just say 100, 100, and let's make it a square of width 2. Okay, so it's not going to be real overpowering. It's just going to be clear enough to show you what piece you have selected. And now let's just do the same thing, except I've decided like when white is playing, if they have a piece selected, we'll say that highlight it red, draw pieces like available moves in red. When it's player 2, we'll just do blue. So we'll have a classic red versus blue going on here. And then instead of this being white locations, it's black locations. Okay, Control C and black locations. Okay. So again, I don't think that this is going to do anything until we actually handle selecting pieces, but now we have, yeah, and it's not. But if you want to test it, we could actually make, let's just go ahead and make selection equal to 10, right? That's a piece that we should actually have. Okay, and you can see it's telling me, oh, you have this pawn selected. All right, so we didn't select that pawn, but that tells us that that little animation that we put in is working. All right, so I think that's pretty much it for the draw pieces. We won't worry too much about drawing discarded pieces until we actually have started capturing pieces. So I'm pretty happy with the draw pieces. I think what it's time to do now is handle selecting a piece and updating what turn step it is. So going from step 0 to step 1 to step 2, step 2 to step 3. So we'll take a look at that next. All right, so basically everything with updating the stage of the turn that we're in is going to happen in our event handling. So it's basically when we click, we need to check a series of things to see basically, did we just click on something that should do something meaningful for our game. So to do that, we need a new category of event handling. Now we need to add in if event.type is equal to mouse button down, and event dot button is equal to 1. Okay, so this is something that, this is not just mouse button down, it's PyGame dot mouse button down. Okay, but this and event button equals 1 is how I check that it's just a left mouse click. PyGame is able to process mouse scroll wheels as well as like side buttons and right buttons. So I just want to say if I intentionally click on it with a left mouse click, then I want to do kind of all of the processing we're about to put down here. So what we want to do is we want to figure out our X coordinate and our Y coordinate as it exists in the grid. So that means Our x coordinate is the event.pause. So PyGame has this built-in event.pause, which is going to tell us the x and y coordinates of the mouse click that just happened. And saying we want 0 is the x coordinate of the click that just happened. But on our grid, each square is 100 wide. So our actual x coordinate for the grid is whatever the x pixel coordinate was divided by 100. And again, floor division will round down to the nearest whole integer. And so we'll do the same thing for y coord, but it's event pause 1 floor divided by 100. And then our total click coordinates, because it's going to be useful to have it as a tuple, because that's how we have all of the coordinates of the pieces stored. So our click coordinates, this variable we just made, is just equal to the x coordinate comma y coordinate. All right, and now we have a little bit of variation based on whether it's white's turn or black's turn. The code is going to look very similar, but depending on whose turn it is, we're going to do slightly different things. So what we'll do is we'll say if turn step is less than or equal to 1. Okay, so I know before I said if it's less than 2 for the white player, but we'll say less than or equal to 1 here, just so you can see that you can write the same code in multiple ways. That's what I'm going with anyways. What we'll do is we'll say if the click coordinates is in our white locations list, right? So we have a list of all the x and y coordinates of our white pieces, and it's white's turn. So what that means is we have just clicked on a piece that is one of our pieces, whatever player's turn it is, it's one of our pieces, and so we want to select that piece. So what we do is we say that now the variable selection is going to be set equal to white locations dot index of whatever click coords is, okay? So whatever piece has that location, we want to grab the index of that piece, okay? So that's going to tell us what piece we just selected. Now what we'll say is if turn step is equal to 0, then we want to just say turn step equal to 1, okay? Because to be in turn step 0, that means you don't have anything selected. Now you've selected something, so we've entered turn step 1, all right? Now what we're gonna do is we're gonna say, okay, if we have just clicked, so if our click coordinates is not, right, so this is going to execute first. If it's in white locations, then we've selected a piece. This is also going to let you change what piece you have selected if you're already in turn step 1. You'll be able to stay in turn step 1 and change your selection, so don't worry about that. But now let's say, okay, maybe click coordinates was in my list of valid moves, which I know we haven't done all the checking yet to see what each piece's valid moves are, but we've already made the list that we're going to store valid moves in. So if our click coordinates is a valid move, and let's go ahead and say selection is not equal to 100, right? Because that's our dummy variable. So we don't want to be able to click somewhere random and move without a piece selected. So, but if we do this, that means we have just clicked on a square that we are allowed to move that piece to. So what that means is we need white locations to update that piece. So at selection, white locations at selection should become set equal to the click coordinates. All right. So whatever piece we had selected, it's allowed to go to wherever we clicked. So we update white locations at selection equal to our click coordinates. Okay. Now what we want to do is check if the click coords is in the black locations. That means that we are playing as white. We have clicked on a place. See how this is underneath its invalid moves? This is the most important one, is that it is a valid move. Now we're checking to see if that valid move also takes us to the piece where a black piece was sitting. And so if it is, then we need the black piece, black pieces, not black pieces, just this one black piece is going to be equal to black locations dot index of, okay, so kind of just like what we did up here, we're checking what piece it is that we just took out. So we're checking the index of the piece that has those coordinates. And what we do is we say, oh, okay, captured pieces so a piece that white has captured, and we're going to dot append now black pieces at black piece. Okay, so again, this is an index. Black piece, that's an index, and black pieces is the list of all the pieces. So we're adding whatever piece we just captured to our list of captured pieces for the white player. And then what we're going to do is pop, so black pieces dot pop, which is remove that black piece from our list of the black player's active pieces. Okay, and then also from black locations, we're going to dot pop that black piece as well. All right, so this is removing the piece that the white piece just landed on from our pieces and our list and our locations list, but we're adding it to the list of captured white pieces. Okay, so then what else we're going to do, that means that if the so actually outside of the popping of all these lists, what we'll do now is we'll say, okay, well, we've just taken a turn and we've moved a piece, which means we want to calculate all of the new options for, so black options are going to be equal to checking all of the options of every piece and getting a list of all their valid moves. And so this is not a function that we've built yet. It'll be the next thing that we build. But the white options, again, not a variable that exists yet, will be equal to check options of the white pieces as well. So let's go ahead and just throw down a list of function to check all pieces valid options on board. So if you think about it, the total places that you can move really only updates when a player or piece moves or is captured. So we'll make this function check options, and for now I'm just going to put pass in it so that the game stops giving me an error. But let's go ahead and say that after we've clicked to move a white piece, then we are going to check the options for the new board for both sides, and then we'll move turn step to 2, okay? And then we'll put selection back to 100, our dummy variable, and then we'll clear out the valid moves list, because every time it's a new phase or a new part of the turn, we need to recalculate those. All right, but so to calculate the options of each colored piece, we need to pass in just the list of black pieces, as well as the black locations. And we're just going to indicate to the function whether it's white or black's turn, because it's not actually going to be able to know just from these first two. So we'll use a third variable in that function to say whether it's white's turn or black's turn in there. But also these two lines, I don't want you to worry about them just too much, these checking the options, because we're going to do this next. So this is a placeholder. We're absolutely coming back to it. I totally haven't forgotten about it. But because we've got all of this code for what to do when it's white's turn, so if turn step is less than or equal to 1, we want to kind of copy this and just modify it so that it works for black's turn now. So if turn step is greater than 1, right? If it's 2 or 3, then what we're checking is kind of the same general order of stuff, but we need to check now if click coordinates is in the black locations list, meaning we've selected a piece, and then selection is going to be equal to black locations, so Control C, black locations at click coordinates, and then if turn step is equal to 2, then now we want to move it to 3, because now the black player has selected a piece, okay? Again, if the click coordinates is in our valid moves list and we've selected a piece, then what we can do is say black locations at our selection is equal to our click coordinates, and now we need to kind of flip the script. So if click coordinates is in white locations, and remember this is as the black player with a piece selected, then whatever white piece we just took out, I guess, whatever white piece we just removed is equal to white locations index of click coordinates. And then we're going to add the piece that just got captured to captured pieces underscore black. And we're going to append white pieces, white piece, and then we're going to remove from the white pieces and white locations list the white piece index that we calculated. And then these two we can leave completely alone because it's exactly the same. We need to check options for both the black pieces and the white pieces now that the pieces have been moved and rearranged. And then turn step is going to equal 0, and then we're going to still clear out selection and valid moves. Okay, so if I boot this up, probably the only thing we're going to see so far, because we're not checking all of our piece options yet, all we're going to see most likely is that I can select a white piece. So you can see it's turn step 0, white, select a piece to move. And if I select a pawn, now the text has changed to select a destination, which is great. And you can see I can click on all the different pieces and it's correctly highlighting whatever piece I've clicked on, which looks great. But because we're not calculating the valid moves yet, we can't actually move those pieces anywhere. So it's a great piece of event handling, and I'm confident that once we get our valid moves list and we start taking out pieces, it's going to look and feel great, but we have to do this super important piece of checking the options for each piece. And this is a really big part of chess. It's one of the most complicated pieces about programming chess, is checking the valid moves for each piece, because obviously every piece moves a little differently, but we are at a point where that is what we have to do next, is check the options for each piece. All right, so to do this not just when we take turns, but also when the game boots up, then kind of when this main game loop boots up, we're going to want those same two lines of code where we just initially populate the black and white options list. And now in our check options function, it's time to actually start building this thing out, okay? And so in here, we're going to pass in the list of pieces, the total locations of the pieces, as well as which turn it is, so white or black, remember? And what we're going to return is a list of all of the moves that any piece could take. So this is going to be really important for checking, like if the king is in check, rather than go through and just check every individual piece. And if that's actively checking it, we're going to just make a list of all of the pieces and all of their valid moves. So basically every square that a white or black piece could get to within one turn. This is going to be a really useful list to have. So we'll make this moves list. And it'll just be empty until we populate it. And then we'll have an all moves list. Okay, so each piece individually is going to have a moves list. And then we will calculate those and add them to our all moves list. So I'm sure as we start building this out, that'll start making more sense. But what we'll do is a for loop to go through and say for I in range of the length of our list of pieces. Okay, so whoops, I missed a parentheses. So for I in range length of our list of pieces, then we want to go ahead and say that the location we're actively looking at is equal to our locations list, but just at I. And then the piece we're actively looking at is equal to our pieces list, but just at I. Okay, and this is important because now we're going to go through and check what the piece is, and we have to do a different kind of check valid moves for each piece based on what it is. So we need to start with the pawn, go to the rook, the knight, the bishop, the queen, and the king, and figure out what move each individual piece is able to take. Okay, and so in the true spirit of Python and object-oriented programming, I'm going to make the issue of checking each of these pieces' valid moves a just future problem. I'm going to kick that can down the road a little bit and say if we have a pawn, we're going to make a function called check pawn based on just the location of that pawn as well as what turn it is. So if it's a white pawn or a black pawn, that way we know, okay, white pawns can't move up against other white pawns, but they can move into the space that a black pawn is occupying. So basically we're just going to do a series of if-elifs for every possible type of piece, and we're going to do a so let's go ahead and say elif piece is equal to, and second we'll make it check rook. So we'll say check rook, and all we have to do is pass in the location the rook is currently in, and we actually don't care what turn it is because that is not super important. And then we'll say L if the piece is L if the piece, actually we do need to pass in the turn for the same reason we did for the pawn. Pete, you're silly, man. All right, so we're doing rook, and then L if piece is a knight, then we will check knight. And these are all going to be individual functions that I'm going to build out for, well, we are going to build out together for each piece, and it will work for white and black lists of pieces. So we have pawn, rook, knight, bishop, and that'll be check bishop. And then the last two types of piece are queen and king. So queen and queen and king and check underscore king. Okay? Alrighty, so basically what's cool is regardless of what piece we just checked for, we will have gotten back a list of moves in our list that we just called moves list. So what we'll do is we'll add each list one by one to an overall list of moves. So all moves list. This is going to be every option that a white or black piece currently has once we check through all of these lists. So the check options function in and of itself is not all that complicated, right? It looks pretty straightforward. Where this is going to get complicated now is that we have to go through and we have to build out each of these functions, okay? So bear with me. That's what we're going to get into right now. We're going to go through one at a time, and we're going to check each of the moves for each of these pieces. So I'm going to collapse that down so my screen doesn't get impossible to deal with. And let's start with check valid pawn moves, okay? So the pawn is pretty easy overall. We have define check underscore pawn. We really only have to check in the direction that it's going if it is able to move forward. Now we do have to check if it's in its initial position, because then it's able to move forward two pieces. Or two spaces, and then we also have to check diagonals if there's an enemy in them. Okay, so let's go ahead and say that initially our moves list is empty, there's nothing in it, and we will say if the color, so the turn that we're taking, is equal to white. And this is actually really important for pawns because they can only move in one direction. But so if the color is equal to white, then what we'll say is if position, there we go. If the position of that pawn 0, so X position, and then position 1 plus 1 is not in white locations, then this is basically saying the Y square, one piece below my current spot, is not currently taken up by another white piece, then I'm able to move there. But it's not that simple. We also have to say, and the same position, so let's go ahead and copy that, and the same position is not in black locations, okay? Because the pawn cannot attack straight forward. So I think I gotta put just a continuation there. Is not in black positions, and now we need to check, just make sure it's not moving off of the bottom of the board. So it's currently in less than position 7, okay? Now then, what we'll do is we'll append our moves list with, so moves list dot append, and then the position that we just said you're allowed to move into, so as a tuple, is your current X position, and then your current Y position plus 1. Okay, so this is probably the easiest check for a pawn, is are you able to go one piece in the direction of your color? So for white, that's moving down the board. For black, it's moving up the board. But this is the simplest if. Now we need to go through every possibility. So the next possible spot that a pawn could go is position 0, position 1 plus 2 squares. which again, it needs to not be in white locations and it needs to not be in black locations, but also position 1 has to be equal to exactly 1. So this means you have to be in your starting square as a pawn. Otherwise, you're not able to go into that square. But now, assuming the position 2 squares down from you is not occupied by the white or the black piece, and you're still in your starting position where your y is equal to 1, then you are able to move down there. So we just moves list append the position plus 2. Okay, so there's 2 more things that we have to check, and that's your diagonal attack vectors. So we want to say if position, and now it's going to be 0 plus 1, right? So it's x off to your right. And then position 1 plus 1. So off to your right and down, because we're looking at a white pawn here. And so if that is in black locations, then that is all we have to check, because that means that we have a diagonal attack route at some piece that's a current enemy piece. So we just copy this. And we say, all right, well, we have a diagonal attack vector. Now I'm going to copy that because that's only checking off to one side. So now we need to check off to the left. So that's just -1. And if we can attack to the left, then we get a -1. And that should be it for a white pawn. So now we need to do an else for the black pawns, because their movement is kind of totally opposite of what we just checked manually. Like instead of going down the board the way we have it drawn, they go up the board, okay? So that means if the color is black, or the easiest way to write this is just else, because there's only 2 colors of piece. So if it's not a white pawn, then it is a black pawn, okay? And so now we can take some of this stuff and we can still keep it as is. We just have to be kind of smart in our checking. So your X and Y position, now we're checking for the piece 1 above you, which is a -1. But since we have to check that it's not in white locations or black locations, it's okay to just change these pluses to minuses here on all 3 of these rows. But then position Y has to be, instead of less than 7, now position 1 has to be greater than 0. Yeah, so it has to be at least 1, right? Okay, and so we'll say, all right, then that means I can move up 1 square. Now, similarly, for checking that I'm allowed to move up 2 squares, it's -2 now, but position 1 has to be equal to 6, which is where I start. Okay, and now the diagonal checks are still left and right, but instead of these +1s, they need to be -1s. So that is just 4 spots that you need to change your Y's to -1s. And then also we need, rather than black locations, we need white locations for it to be an attackable position for our white locations, okay? But so this list right here should give us everything that a pawn is allowed to do. So we will return the moves list, all right? And let's go ahead and collapse that. And that should give us everything for checking a pawn. And then checking options is going to give us all of the pawn moves. Now I wonder if there's a way we can test it with just that. So maybe we get rid of these ones so it doesn't throw an error. And this will let us check the pawn. And then this will give us all moves list. And then we can start to check for valid moves if something is selected. Okay, so I think that's what we should do next, just so we can test the movement of pawns and make sure that's working. And then we can start building out all of the valid moves for all of the pieces. But this is a fun way to mix in the next stage of functionality with checking all the pieces rather than just slogging straight through it. So let's do that next. Okay, so let's come under draw pieces, and let's say if selection is not equal to 100. Okay, so that just means we've actually selected some piece. All right, let's get this valid moves list, and let's set it equal to something we'll get back from check valid moves. All right, so this will be something where we take we take out of the total options list, we take out the valid moves for just whatever piece we actively have selected. And I think what we'll do as well is we'll make another function where we draw the valid moves on the screen. So this way, when we get a list of valid moves, we also draw them on the screen. So for this, we need to draw valid moves on screen, and this will be define draw valid. And again, just so I don't get an error for the time being, I'll put pass in here, but we'll come back. We know we need to fill this out. But first, let's go ahead and take a look at how to check for valid moves for just selected piece. Okay, and so this is define check underscore valid underscore moves. Okay, so what we want to do here is we want to check whose turn it is, and then we're going to look into the options list that we just came up with, and we're going to return just the options for the piece that we have selected as our valid moves. So easiest way to do this would be just start check valid moves by saying if turn step is less than 2. Again, that means it's 0 or 1. That means it's white. Then our options list is equal to white options, and then it'll be else our options list is equal to black options. Okay, and that should make sense. And then we can just say, I think we did it right, to where white options at our selected or selection variable should be our valid moves list. So let's go ahead and say valid options, I guess, because we said moves in the outside world. So valid options is equal to white options at a selection. And then let's return the valid options. The valid options. And actually not white option selection. We want just from the options list. So options list, we want the selection. And I think just this little bit of code is going to give us the valid moves for whatever piece we have selected. And so hopefully if we did that right, then this draw valid list becomes really simple. And we can just say if turn step is less than 2, then we will say color is going to be equal to red. And then I think I said blue for the black player. So we'll say else color equal to blue. Okay. And then what we'll say is just for I in range, and then length of, and then moves. So I think we got to pass in the valid moves, which we are. So we'll pass that in as a list of moves. And what we're just going to say is for I in range, length of the moves list that we passed in, we just want to draw a little dot. So pygame.draw.circle on the screen in whatever color we just decided, because that tells us whose turn it should be. And then we'll say the x coordinate should be moves I and 0 for the x coordinate times 100 and then plus 50, because we're giving it a center point here, so we want it dead smack dab in the middle of a square. So we'll say plus 50 to move it into the middle of the square. And then the I coordinate will be moves I 1 times 100 plus 50, just like the other one. And then we just want these to be little dots, so I'm going to give it a radius of 5. Excuse me. Now, full disclosure, we did that pretty quick, so I totally could see us having made some mistake there, but hopefully everything's working to where, oh, let's see what problem we got. Variable I, come on, give me my errors. I have this thing collapsed too far down. List cannot be interpreted as an integer. So I probably said for I in range pieces somewhere where it needs to be for I in range length of pieces. Let's come back into check options. For I in range length of pieces. There we go. So that should solve that problem. We might have other problems. All right, let's see if I click this pawn. Okay, it's giving me 2 circles down here. which is interesting. It seems like we're getting the coordinate math off by a little. But let's see if I click on a square that I know I should be able to move into. It does move the piece, which is cool. So when I click blue, I can't see the circles at all, but it does let me move the piece somewhat accurately. Let's actually see if I can capture. It does. It lets me capture a black piece. So, I mean, just for proof of concepting this game, we actually are doing a lot of things right already. We need to figure out why the circles are drawing so far off. But it's letting us move to the correct location. So I'm guessing it's just an issue with our draw pieces function. Let's dive back in there. Not draw pieces, draw valid. Sorry, there's a lot of draws now. So draw valid, x times 100 plus 50, and then y times 100 plus 50. Oh, plus 500. That'll do it. All right, good job, everybody. We figured that one out. Okay, so, and if you notice, the bottom text is working too. So white, select a piece to move. I click this one. It shows me where I'm allowed to move. And then I pick one of those. Same for blue. Although, interestingly, the blue double up checking doesn't seem to be working. It's moving stuff down there. Okay, so actually, that's what testing is for. But so for some reason, checking the second up for the black pawns is not working. So let's take a closer look here. If our X position -2 is not in locations, then we append, yeah, so we forgot to change that to a -2. So I'm glad we tested it, but still, that's a really fun, let's go ahead and run it just to prove that we got it right. Nice. Now I can move up here, and you can see it even calculates that, oh, I can do a diagonal attack. So that's a really cool little bit of code we just worked up there. Obviously, we don't have any of the other pieces going, but now we have the infrastructure in place where we can really accurately just test it super quickly now every time we develop a new pieces check function. So let's keep going through this kind of check options list here. Let's go ahead and I guess for now, let's just put them all back in play. But actually, we'll probably want to test these sort of one or two at a time. But all right, we've done check pawn. Let's go ahead and check what I put next, rook. So let's check rook moves, okay? So define check rook. And again, we are passing in position and color, kind of just like we did with the pawn, all right? So checking a rook is actually, in my opinion, just as simple, roughly, as checking for the pawn, because it's just checking straightaways. There's not even diagonal checking, which is what the pawn had, right? So, excuse me, I'm gonna take a quick water break. Okay, much better. So, to check the rook, first thing is we have an empty moves list, and the thing we don't want to forget to do at the end is return the moves list, okay? So every piece is going to start with an empty moves list. We're going to check through where it is, and then we will check, we will return an empty moves list, okay? So what we'll do here is we will say if color is white, all right, white, there you go. Then that means that this is a white rook, which means our enemies list, so enemies list, is going to be equal to all the black locations, and our friends list, it'd be nice to have a list of all my friends, is the white locations list. And now we will say else, and we will copy those two lines, and we will just flip them. All right, so else, this is going to be my friends list, and this is going to be my enemies list. And that way, we know when we are hitting a friendly piece or an enemy piece just by flip-flopping those two based on what color the piece that we're passing in is. Okay? So, very cool. Let's go ahead and say for I in range length of 4, because this is going to be our loop for checking up, down, right, and then left. And hopefully, I'm hoping we can make it to where we have some overlapping code. All we have to do is calculate, okay, when I'm going up, my X position doesn't change, but my Y position needs to decrease. So you need to subtract 1 every time to go up. As I go down, my Y position changes in the positive direction, and then right and left, my X position changes left or right, but my Y position doesn't. So what that means is we can set up kind of something to check if we have a valid path, right? So if there's 6 pieces in front of me, all of them open, I have this continual path and a total chain length of, well, it'll start from 1, I guess. So if we find a piece is open, then the chain of pieces in our path is 1. But then every time we find another piece to continue on with is open, then we will extend that chain value. So check this out. What we'll do is we'll say if I is equal to 0, and remember we said that would be up, then x change, so essentially our x variable is going to be equal to 0, but our y is going to be equal to 1. Actually, I did down first and then up, so we'll do it that way just so I don't get I don't go insane. All right, so L if I is equal to 1, then x is still going to be equal to 0, but y is going to be equal to -1. And then L if I is equal to 2, because remember, we're doing a for loop, and we're going to check all the valid moves for a rook in one kind of smart algorithm based on whether x and y need to be changing. So then x is going to be equal to 1, and y is going to be equal to 0 because we're going to the right. And then we will just say else, because the only other thing we'll be doing will be x is equal to -1, and y is still equal to 0. Okay, so the nice thing about a rook is as soon as you run into a collision, you don't have to keep checking down that line. You've hit a wall or you've hit a piece and you can't move any farther. So what we can say is while the path is still valid, so that true false boolean we made called path, while path is true, we want to keep checking, but once path is false, we can move on, okay? So what we can say is if our position 0, so x position, plus whatever chain we are on, so if it's 1, if it's 2, whatever, times our x modifier, comma, position, and bear with me and I'll kind of recap it once we get it typed out, but our position y plus our chain times our y modifier, and when that is not in the friends list, and 0 is less than or equal to our position 0. So again, guys, bear with me. I'm going to go back and recap this whole checking algorithm here in just a second, but I just want to get it all down so that I'm not talking and coding a ton. We're trying to get complicated stuff down, okay? Our x position plus that chain times our x modifier needs to be a valid move that is on the board, so between 0 and 7. And same thing for our y. So 0 has to be less than or equal to position 1 plus our chain times y modifier. All right. And that also has to be less than or equal to 7. Come on, less than or equal to 7. There we go. And so if that's all true, then we can append to the moves list. So moves list dot append, and then we can say the position is position 0 plus the chain times x, and then the y is position 1 plus chain times y. So come on, chain times y, and then like 3 parentheses to close it out. Yeah, because we want to append this as a tuple. So there we go. All right, so I think that works for checking if it's open. So we need a continuation here too, I guess. All right, so this should check if we have an open path going forward. So that's great. But then what we also need to do is we need to check if it is an enemies list, because if it's in the enemies list, we need to break it. So what's going on in this function, to recap, when we want to check if we're allowed to move to the right, remember x is equal to 1 and chain starts as a 1. So that means that the first position we check is our current y position, because y is equal to 0. So this whole piece becomes equal to 0. So this is just checking our current y position plus 1 to the right of our current x position. And if that's not in the friends list, if you think about it, if that is not a friendly piece and that spot, that position 0 to the right, is between 0 and 7, then we can move there. Whether it's empty or whether there's an enemy there, we can move there no matter what. So that's why we append it to the list. But what we need to check next is if it is in the enemies list. So we can take that whole first bit, not in friends list, and we can say if it is in enemies list. So if that spot is in enemies list, then we want to make sure that it's in our valid moves list, but it should already be in there. But then we need to set path equal to false, because that is as far as we can go, right? So then we set path equal to false now. But otherwise, if path was true, because this is a while list, then we go ahead and we say, so for this first if, else chain plus equals 1. So the way we end up breaking the path is if, not else chain plus equals 1. Okay, so let's do this one step at a time. I'm getting ahead of myself. First we check, and this isn't just for the right, that's just what I used for an example. This is for any direction. We're checking to see if we can continue going in that way. So it's either empty or an enemy if all this first stuff is true, and that means that we can add it to the moves list. But if it is an enemy, then we need to do this additional thing and say, okay, then the path is actually false now. We can't go any further in that direction, but whatever happened here, we were able to move, so we add 1 to the chain variable. And then what we say down here is else, and then else path is equal false. So this is the only valid line of code that would say we are able to go in that direction for any of the 4 directions. It has to be saying that whether we're going down, left, right, or up, it has to be an empty square or it has to have an enemy in it. Those are the 2 conditions that allow us to move in that direction with a rook. And then if there's an enemy in it, we can't go any further in that direction. But if this is not true, or if it is, we don't really care, we can add 1 to chain, because then the next time we check, we'll be checking the next square in that order. But if that is no longer true, we set path equal to false, we break this while loop, and then we move on with our lives. So this is a really cool, I think, cool way of checking all of the valid moves for a rook. So I think we need to maybe savor the fruits of our labor now and go ahead and test that. So let's go ahead and comment out the knight, bishop, queen, and king. We'll get to them. And let's see if we can't, moves list is not in here, but all moves list is. What did I do? This worked before. List is not callable. So I must have called something in the outside world moves list that I shouldn't have. Let's take a look. Oh, the whole stupid error is that I said return moves list with parentheses, but it is just a list. So I think that was the only issue we were getting. All right, so nope, something else going on. Check valid moves, list index out of range. Okay, let's take a look. Oh, I was a little too hasty to do testing, and I accidentally commented out the row for all moves list. We do need this row regardless of how many pieces we're not ready to check yet, or we're going to keep getting rid of our list. So, all right, let's try and free some rooks. So let's move these pawns out. Bam, and we can move this rook out this way. That's great. Let's see if we can move these guys. And look at that. It's showing us all the directions we can move these pieces in. It seems really, really good right off the bat. It lets me go onto this black piece, but not onto the white pieces. It lets me move in all 4 directions, which is great. You can take out pieces with the rook, so that's really cool. This is working really well. For some reason, it did treat this king like a rook when we clicked on it, but I think that's just because we haven't put in checking for anyone else just yet. I guess without any further ado, let's keep going on the piece checking. We've got the rook, we've got the pawn. It's going really well. So I guess it is time to check the knight. And just preemptively, so that I don't make those mistakes again, I'm going to leave these 3 commented out, but make sure this guy stays put. And let's check the knight. And so there were kind of neat little algorithmic things we could do for checking the pawn, the rook and the pawn. But actually for the knight, it's just kind of a frustration because they move in such funky ways that really the only good way to check for the knight is to individually look at sort of each of the targets of those knights and check if that piece is occupied by an enemy or if it's empty. So let's just get into it. So our moves underscore list is going to start out empty, and we're going to return the moves list, but we're not going to put parentheses on it, right, everybody? Right. Okay, and actually we are going to go ahead and steal something smart that we did here in the beginning, this if color friends and enemies. That is going to be pretty useful for every single piece now. So for checking the knight, if it's a white piece, then we want to say that the black pieces are enemies, but if it's a black piece, then the black pieces are friends and vice versa. Okay, so there are in total 8 squares to check for knights. They can go 2 squares in one direction and 1 in another. Okay, so all in all, this leads to a circle of 8, sort of a circle of 8 targets that they can attack. So to list these out, they can go 1 to the right and then 2 down, or they can go 1 to the right and then 2 up, or they can go 2 to the right and then 1 down, or 2 to the right and then 1 up, and then they can go 1 to the left and then 2 down, or 1 to the left and then 2 up, or 2 to the left and then 1 down, or 2 to the left and then 1 up. Okay, so these in terms of our coordinate grid system, these are the 8 targets that a knight has to check if it's able to move into. And so all we have to do is say for I in range, and this time we can just plug an 8 in here because those are the 8 places a knight can move. We will say the target square is equal to, and this is going to be a tuple, the position of our knight, so position 0x, so that's our x position, plus targets at I. Remember, this is a for loop, so we're going through and grabbing each of those 8 targets at I, and then 0 is the x adjuster. So when we want to check a piece to our right, we go ahead and we check targets at I, so that's going to be 0, 1, 2, 3, 4. We're checking targets at I, and then the first term in there, which is the x coordinate. We add that to our current x coordinate, and then our position y is the same deal, but we add targets at I and then position 1. And that is how we check the target. And what we need to do is we say if target is not in our friends list, so that means that we don't have a friendly there, and target 0 is between, so it needs to be less than or equal to 7, but it also needs to be greater than or equal to 0. So that means it's a valid square. And same deal, but for the y coordinate. and that. So these are the only three things we need to check, because this means that it is a square that is on our board and that it's not a friendly. So we don't actually care if it's an enemy. It's not going to like break a chain like it would with the rook. So basically, moves list dot append our target. Okay, so that should be the knight, and this should be a really easy one to check because, yeah, actually we didn't even need enemies list, but that's okay. This should be a really easy one to check because here we go, check valid knight moves. I know the inconsistency in my commenting drives some of you guys crazy, and I get it. I'm sorry, I'm trying to be better. So let's just try to move this knight. That's really cool. I can move to these two spots, okay? And then this guy too. And now it's checking 8 squares. And you can see this time I get 5 options. This time I've got 6. I'm moving down towards the enemy pieces. Now I can move to any of the 8 squares and 4 of them would take out enemies. That's really cool. In my opinion, that is a great little algorithm we just wrote. So that's awesome. Let's continue on. I think the next thing to do would be the bishop. Because actually what you'll see is the queen is going to be pretty nice. If we do it nicely, we should be able to piggyback off of the check rook and the check bishop functionality. Because if you think about it, the queen's valid moves are a combination of those two. So I don't want to get ahead of ourselves. Let's go ahead and check the bishop moves. But I think we're going to be able to do something pretty cool for the queen when we get there. So let's go ahead and check the bishop. It will have position and color as always. And then we will go ahead and copy in the friendlies checking just like the other one. Moves list as well. Might as well grab that. And down here, we will just make sure we return moves list. And we won't put parentheses on it. Great job, everybody. It wasn't just me making that mistake. We all made it together. All right. And so this time we're actually going to use, maybe I should have just copied the modifier too, because we're going to do something as simple as we can with pathing and checking for chains, because it's the same. It's just instead of moving in straight lines, they go in diagonal lines. All right. But so check this out. So we do the same friends and enemies list that we were going to do for the rook. And then what we do now is we're still going to do these 4 directions, but instead it's going to be up, right, up, left, and then this will be down, right, and down, left, okay? But we can still create some sophisticated direction checking, all right? So path is equal to true, chain is equal to 1 when we start out. I of 1 will be, what we say, up and right, so that means x is 1. Anytime you see something going right, x is 1, and anytime you see left, x is -1, okay? And anytime you see up, y is actually going to be equal to -1, and anytime you see down, y is going to be equal to +1. So no zeros here, which is kind of cool. And now we're going to make an algorithm actually very similar. Actually, it might be the same algorithm. Gosh, let's go ahead and see. So if I copy this in first, let's go ahead and talk about if that works. So because we have the proper x and y modifier, we're still checking if our x position plus our x modifier and our y position plus our y modifier is not in our friends list, and it's a valid square that's on the board, then we can move to that piece. But then if the position is an enemies list, then we need to stop moving in that direction. Otherwise, we want to keep adding 1 to the chain. And if that condition is not true, we can't go in that direction. So I really think that it's super close to what we did for the rook. It's just we need to change our modifiers to being these diagonals rather than these straightaways. So this should be just an amazingly simple modification to the rook to get the bishop working. Let's go ahead and check that out. And hopefully I didn't forget to add some conditions in my eagerness. So look at that. I can get the bishop out diagonally, which is sweet. Let's go ahead and move him here. Let's move this bishop out here. And it looks pretty good. I can move in all 4 directions. I can capture this pawn. I can go in here. I can capture the king, which isn't great. You shouldn't be able to do that. But all right, this is really, really cool. Let's go ahead and take a look at what to do with the checking valid for the queen, and then we'll do the king last. Not a problem. Okay, so bang, let's go ahead and check the queen valid moves and define check underscore queen, and we will say position and color. No surprise there. Okay, and let's see here. What can we do to be clever with the check queen algorithm? Okay, I think this is valid. I think what we can do is we can just get our moves list equal to check bishop with this position and color, and it's going to return a list of moves as if, so second list, this moves list is going to return a list of valid moves as if our queen was a bishop, and then this second list will return check rook. Will return a list of moves as if our queen is I don't know why I put colon there, as if our queen is a rook. So this alone is going to give us two, I don't know why PyCharm throws so much syntax at me, which is awesome. But sometimes I just want to keep writing code and I'll fix my syntax later. But so this is really cool. What we can do now is say for I in range length of our second list, let's just go through and add each of those moves individually to our first moves list. So moves list dot append second list at I. Okay, so again, this is going to be a list of tuples, so we just want to add each of those tuples individually to our overall moves list. But this is a really cool and, in my opinion, elegant way of combining the work we already did for the bishop and the rook for our queen. Okay, so if this worked properly, I'll be thrilled. Let's go ahead and see if we can get our queens out of the box here. So all right, I got queen. I can move it forward, which is good. That should be all the queen can do. Now look at that. We've got diagonals. We can take out this pawn. We can go back up. We can move straightaways. So this is really, really cool. I mean, now we have these dueling queens. But this is just great. Look at all those moves that queens can have. And it's not just queens now. We're up to every single piece except that king. And that king is not going to be too bad. Let's go ahead and just knock out this section. We are on to the last piece. And we're going to check what valid moves the king can take. So define check king. I don't know why I typed the actual code instead of check king valid moves. All right, define check underscore king, and we will pass in again position and color. That seems to be the thing to do. All right, and then we will have an empty moves list. I don't know why I can't be consistent. And then I will return the moves list at the end of this bad boy. And what we're going to do in the check king function is, well, we'll steal the same friendly and enemy lists that we have previously defined. So this guy right under moves list. And then let's go ahead and say there are 8 lists to check. So actually, let's go to where we had the knight, because that was pretty straightforward. We just had a checker of all 8 of our targets. And similarly, the king can target 8 places. So these are 2 indented. We need 8 squares to check for kings. They can go 1 square any direction. Okay, so that means that this would be, instead of that, it would be 1 0, 1 1, and 1 minus 1, 1 comma minus 1, and then it could have minus 1 0. Oh, what is going on? Minus 1 0, minus 1 1, and minus 1 minus 1, and then 2 where the x position doesn't change. So this would be directly up and directly down, 0 1 and 0 minus 1. Then for I in range 8, target is equal to the position plus target's I0 and position 1. So it's just like the knight, and we check that it's not in the friends list and it's on the board, and that is it for target. So how cool is that? The knight gave us the vast majority of the king's list, and the rook and the bishop gave us the entire queen's list, and actually just doing the rook intelligently gave us most of the bishop's list. So this is just a really cool example of reusing code when we have similar applications or overlapping applications. So we could test the king. I feel pretty good about it, and I want to add in one more thing before we go back into play testing. I want to draw captured pieces on the board as well. So we have been doing we've been drawing pieces, and they've been going away when they've been getting captured, which has looked great. It's looked really good. But they have not been, what am I trying to say? They have not been getting shown on screen when they get captured, okay? So let's go ahead and just come down under draw valid, and we will say draw captured pieces on side of screen, okay? And so to do that, we will define draw captured, there we go. I don't know why and that needs parentheses, Pete, man. Struggle bus. It's these long tutorials, you guys. I'm trying. All right. And then what we will say is for I in range length of the captured piece is white, then we will just go ahead and say the current captured piece, so a little temporary variable here, is equal to captured pieces white at index. And then index, and that might sound silly, but remember back to when we first drew those pieces on the board, we have to figure out what index belongs to them on our piece list so that we can figure out the right image to use. So the index of the captured piece, okay, getting click happy. I can sense we're close to the end. All right, so screen.blit, these small black images, and remember, captured white pieces, so these are pieces that the white player has captured. These are black images, okay? So small black images at the index of the captured piece. And then for X position, I'm going to make the the black captured pieces, the ones that have been captured by the white player, I'm going to draw them further to the left, so at 825, and then I will move them down at a rate of 50 pixels per captured image. They're all 45 by 45 squares, so that'll probably look pretty good. And then I'm going to copy this entire thing, and I'm going to do the same deal for now for length captured pieces black, and then the index will be captured pieces black, just like that, and then piece list index, just like that, and then this will be small white images, okay? And so this is just gonna be a quick loop that cycles through and draws all the captured pieces. These will move to 925, so they'll be off to the right. But now we should have a playable two-player chess game where when I boot this thing up, if I capture a piece, it should show up over on the right. So let's see if I can just capture a black pawn. Bam, there's a black pawn over there. Okay, so how cool is that? Maybe you guys don't think it's that cool. I think it's pretty cool. Alrighty, so let's go ahead and just capture a few pieces, but not a king. We just don't want to ruin the game. So I'm just jumping around. I don't know why I'm using just queens. I think it's just because they move so quickly. But I could be moving with any piece here. I could use my knights if I so chose. Bang. All right. So clearly you can see the captured pieces stacking up on the side as they get removed from the board. And I think it just looks really good. It's really fun. It reminds me of classic chess when you actually get to see all of your dead pieces off to the side, like a little chess piece graveyard. So I think probably the best next thing to do is we should handle winning conditions. I'm not going to spend too much time going through an official like checkmate capturing. I'm just going to, what I'm basically going to do is I'm going to make it like classic chess, like gentleman's chess. I'm going to make there a like forfeit button. When it's your turn, if you see that you're in check and you can't get out of it, you can just hit forfeit to surrender. But so we need to make a scenario where you can either forfeit or a king actually physically gets captured. So we can make it to where when the king gets taken off the board, that's also a defeat. So I know strictly speaking in chess, the king is never actually killed. You just checkmate the king, but this is a little bit easier way to go about it. So how about the next thing we do is we just visibly show if a king is in check. That could be something that looks kind of good, just to show that you are in check, to remind the player. Okay, and so for what I have in mind, I would like to see a like flashing rectangle if the king is in check. So what I'm going to do is I'm going to come directly under my timer.tick, and I'm just going to make a flasher that will flash through its cycle twice per second. So I'll say if my counter, which that variable I made a little bit earlier, or maybe I didn't, when I made all these other variables, I don't think I ever made a counter. Oh yeah, I made a spot for it. So counter will start out equal to 0, and we'll just basically use it as a flasher. Okay, so if the counter is less than 30, then what we'll do is we'll just say counter plus equals 1, and then we'll say else. That means it's hit 30, counter is back equal to 0. So this will just be a variable that'll count to 30 and go back to 0. But now what I want to do is I want to make a new function that I think we'll call draw check. Okay, so draw underscore check. And what we will say is under draw capture and all the other drawing things. And if you're looking for a way to reduce number of functions, you could probably combine a lot of these drawings, but it just really helps make it clear what's getting drawn in each section. So draw a flashing square around king if in check. Okay, and this is going to be pretty easy. We will both check to see if the king is in check and draw a flashing square around them just inside of this function. So let's make a variable called checked. All right, and we'll say if turn step less than 2, that means it is the white player's turn. So what we care about on this turn is if the white king is in check. And so the king index is going to be equal to white pieces dot index of the piece that is king. Because if the king is not on the board, then the game is already over, so we don't need to check this anymore. So the king's underscore location will be equal to white locations at index. So at king index, like that. And now we have the index, the location that the king is currently in. So what we need to do is say for I in range length of the black options list. So this is all of the black pieces and what their current moves are. We need to say if the king's location is in the black options list, right? So if the king's location is in the black options list, then what we'll say is if the counter is less than 15, we'll draw a rectangle. So this is how we achieve the flashing, because every 30 clips, which happens every half second, that counter will go from 0 to 30, 0 to 30, 0 to 30. And so for half of that time period, we'll draw a rectangle on the screen. So pygame.draw.rect, draw it on the screen. And if it's the white player who is in check, we will make it a dark red rectangle. And then where we do it is just going to be white locations at the king index, and then position 0 because it's the x, and then times 100, and then plus 1, and then we will say white locations, king index, and then position 1 times 100 plus 1. So those rectangles should look familiar, and then it'll be 100, 100, and we will make it a border thickness of 5. Hopefully that rectangle looks familiar to you guys, because that is basically the same rectangle that we draw on the screen. What am I trying to say? That we draw on the screen when a piece is selected. This one is just dark red instead of light red and a little bit thicker. Okay, and so that will be enough. It should be enough to draw a dark red circle on a checked white king. Let's go ahead and say now if the turn step is greater than 1, so 2 or 3, or we can make it an else. Oop, what's happening? This could be just an else. That's fine. And what we will do... Oh, I guess we don't need this variable checked equals false. Let's get rid of that. That was stupid. But now we need to say instead of white pieces, it'll be black pieces there, and then it'll be the black location for the king. And now we will say for I in range white options, if the king location is in any white pieces space, then let's make this dark blue instead of dark red. But then these need to be black locations. So black locations to correctly draw the square. All right. So again, kind of doing that fast, and we're kind of deep into this game build now, but hopefully if we did that correctly, when we get a king in check, which I can do fairly quickly, hopefully. When I get a king into check, it'll start flashing. Nope. Int is not subscriptable. All right, well, we're getting close. Let's go to line 340. Something we just drew is not subscriptable. That's okay. Black locations. Let's push that a little further. What does it say? Black locations, king index 1, object is not subscriptable. Oh, yeah, we're just missing a close brackets on that king index, so I think that is all that issue was, but now it does look like we have one too many square brackets here, I'm thinking, and I think here's the same issue. Yeah, here is the same issue. That just needs to be a square bracket that closes off the rectangle definition, and then we don't need that back one. So hopefully that fixed it. Let's put that king in check real quick. I want to see the flasher working. So that was kind of a stupid move. Okay, so it is the white player's turn, and I guess I would think you would want to be flashing right now because you should be in the queen's line of fire. Let's put the okay, let's put the black king in check. No? All right, let's see. All right, so that does not appear to be working. Let's see. Well, I'm looking at this. I don't think the problem necessarily is with our code. I think it's that we made these width of 1 and height of 1 when they need to be width and height of 100 to actually show up. I'm hoping that's all the problem was. Let's take a look here. I'm sure I can put someone in check. Bam, there you go. Okay, so a dark red flashing square letting you know that your king is in check. And if you take care of it, then the king is no longer in check. So that's pretty good. And let's go ahead and put the black king in check. And the dark blue works. Now, the one thing that real chess probably wouldn't let you do is have all these valid moves out here if you're still in check. Because if you take a move and you're still in check at the start of a turn that you were in check on, then you would lose. But the thing is, these are the moves that a knight is allowed to take. These are the moves that your pawn is allowed to take. So we could do a very complicated, like, don't let you check, don't let this move, this move, this move, or this move count as a valid move if your king is in check. But we're making it pretty flipping clear that you're in check. So what we'll do next is we'll add either a forfeit button, or we will just make it to where if the king gets taken out like that, then the game will end automatically with a winner if the king actually gets killed. So in traditional chess, I don't think the king actually gets killed, but this is a video game, so it'll be way more fun that way anyways, okay? And so I think what we need to do is we need to start just by saying up here, if let's put it in here, I guess. Let's say if king in white pieces. So if king is no longer in white pieces, we don't want it to error out. We want it to let you restart. So if someone actually does take out the king, we don't want to error out our check thing here, because what we saw there that ended that is we killed the king and then it threw an error, but we want to handle that internally on purpose. Okay. All right, so let's get rid of the draw check for now. Let's let it auto reformat because I'm sure it has strong feelings. And now let's handle what to do if the king gets taken out. All right, let's start by making a variable that we will just call winner. And we will initially have it be equal to just an empty string. And so this way we can use one variable for the black player winning or the white player winning. Okay, so let's go down to where we check if we need to pop a piece out. And let's check, because we're already checking the piece that is getting removed, right? It's this black pieces at black piece. So it is this guy. What we need to do is check if black pieces at black piece. And we need to do it here because if we come down and try to do it at the end, it'll already be gone because we've removed it, okay? So if black pieces, black piece is equal to king, then we need to set winner equal to, and this is going to be on white's turn. So winner would be equal to white. Okay, and then we will just kind of copy this whole rung down into before the popping right here, and we will say if white pieces at white piece is equal to king, then the winner will be the black player. Okay, and now down here, let's go ahead and just say if winner is not equal to empty, then that means game over, and we'll make that a function. So game over, let's do two things. So we'll say game over is equal to true, and then let's make a function called draw game over. Okay, so let's come up and say up here that to start out, game over is equal to false. All right, and now game over is equal to false, winner is equal to this empty string. And now let's say, oh, okay, winner is equal to something other than an empty string. Game over is true. Let's draw the game over stuff. So what we'll do is say define draw game over, bang, and then here we will do PyGame dot draw dot rect, and we will put it on the screen, and we will just make it black, which will look sweet, and we'll put it kind of right in the center. So we'll go X starting position 200, Y starting position 200, and we will make it 200 wide and 50 tall. That should be enough for, let's do 400 wide and 50 tall. That should be a big enough rectangle to put like text on. And then it'll be solid. And so then let's do so let's do font.render, and I'm just going to use the regular font. And the text is going to be, let's make it a formatted string so we can say who the winner was. Let's say winner won the game. And then, okay, so what else do we need to put in a font.render? Anti-alias is true. And then the text will be white because we're drawing it on top of a black rectangle. So let's do screen.blit on the same line because I'm just freaking reckless right now. And so the X starting coordinate will be 210. That'll move it off the right wall a little bit. And the Y starting coordinate will also be 210 because we'll see how that looks. Bam, coughed. All right, so that's X and Y starting coordinate, and then the text will just take up as much space as it needs. And then let's do a second line of text here, Control C, Control V, and let's say press enter to restart or play again. Restart works, okay? And let's just put it below. So let's make it 70 high, and let's put this down to 240. Let's try that. Maybe that's awesome. And I know what you're thinking. Will enter actually restart the game? No, not yet. We're just displaying the stuff on the screen, okay? So let's come back down, see why it's throwing errors. There is a colon expected at, what, 408? Why? Oh, yeah, that's a good reason. And another colon expected at 389. That's why I like PyCharm, guys. It tells you what's wrong before you get errors a lot of the time. So let's boot that up. Let's see if we can actually take out a king and get a game over message. All right, so bang, bang, king's in check. Gonna come down here. Oh, why didn't I stop that? Okay, so black won the game. Press enter to restart. It is interesting. I'm thinking I'm drawing it at a weird spot. Because, oh, I'm probably drawing it inside the event loop. Yeah, so just pump this out, one indentation, if you made the same mistake as me. But okay, the text was appearing there, which is good. So what I want to do is I want to make it to where all of this clicking, all of this mouse button down and event button 1 stuff, I want to do and not game over. Okay, so I want to do and not game over. That way, if I click on a piece and I try to move it anywhere and game over is true, then I don't want it to work. So what I want to do here is I want to make a new if event.type. So I want to say if event.type now is equal to PyGame dot, and this will be key down. Yeah, okay, key down and game is over. Okay, so that means it is game over. If event dot key is equal to pygame dot k underscore, and it's actually k return. I've talked about this in past videos. The enter key is return for Pygame. A lot of old keyboards, maybe some still do, but a lot of old keyboards said enter there. Okay, so that's why it's k return. But okay, so if you have hit enter when game over was true, that means that we want to start a new game up, and there's actually a lot of stuff we've got to do here. Okay, so we have to do game over is equal to false first of all, and we need to set winner back equal to this, but then we need to kind of reinitialize all of our lists of pieces and places. Okay, so we need to reset all 3 of these white pieces, captured pieces. So very similar to the initial variable setup we had in the beginning. We need all these things to happen, and then we also want to set turn step, valid moves, and selection. And we don't have to worry too much about any of the other lists. They weren't getting messed with. But this whole thing should be enough to do it. Let's go ahead and see real quick if we can get a restart going. So we'll take this pawn out, we'll take this pawn out, go over there, go over there, go over there. I don't know, I feel like I'm doing something less than ideal right now. Okay, this guy is in check. This guy's in check. White won the game. All right, press enter to restart. What happens if I press enter? Well, it still shows the king in check. Oh, yeah. Because we need to also reinitialize the options when we restart the game. So it was holding on to previous options, okay? So valid moves is like that, and then we redo the options, and then everything else should be golden. Now, last thing, let's go into draw board, because like I said, I want to put forfeit as an option. Because if you're doing really, really poorly, it's a gentleman's game. You can hit forfeit. I mean, it's also for ladies. In fact, I think ladies are probably better at chess. But you can hit forfeit if you want to at any point and just say, like, I give up, okay? So in that bottom right corner, if you remember, we drew these two squares, and the bottom right one is just a square of 200 width and 100 height. Let's go ahead and do one more font, so screen.blit of another font.render. So we'll try big font. It might be too big, but big font.render, and then here we're just going to say forfeit. Okay, and we don't have to worry too much about whose turn it is, because we can check at any time whose turn it is, and if you click forfeit on your turn, you're giving up. Okay, so if you click forfeit, then we want true, and we will make it black still. That's the color of the text out there. And then in position, we want to make it, let's say 810 over to the right, because we have 200 to work with, and we only have 100 from the bottom, so maybe 910 is good. Let's take a look at how that looks. And it doesn't even show up. Screen.blit, big font.render, the text, anti-alias black, 810, 910. I'm thinking 910 is the issue. Yeah, it's only 900 tall. So let's try 810, 810. Let's take a look there. Okay, so forfeit is too big with our big font, so let's just do regular font. Forfeit, and that looks really small. All right, I'm doing it. I'm going up to the fonts, and I'm making a third font that I will call medium font. Medium font, and we will make it 40. Okay, so now let's go back to forfeit, and let's say, rather than font.render, medium font.render, keep our positions the same. Take a look at that. All right, forfeit fits. I'm going to scoot it down just a little, and then we are going to move on from this, because the important thing is actually clicking on it. 840 was too much. So how's 830 look? Pretty good. All right, I like it there. So you can play around with this style all you want if you want. I think we're getting pretty darn close to a completed game. And so what I want to do is, in the mouse button checking, essentially where we have the coordinates, so if mouse button down and not game over, we can check in here if click coords, is equal to. And let's think real quick about what square or squares this would occupy. So this would either be all the way to the right or one square before that to the right. But we already have this checking of blocks of 100 by 100. So what we can do is we can check if the click coordinates are equal to either, let's see, we do floor division, it's 1,000 wide. So either 8 or... so 8 comma something, or 9 comma something. So let's see, it's 900 tall, which means it would be block 8 or 9-8. Then we just say that winner is equal to black, because white just forfeit. And then we can come down to if turn step is greater than 1. And we can say the same thing, but that the winner will be equal to white. So I did that kind of hasty. This is not something I had in my original build, so let's just check it out. It's white's turn, right? So he's looking at pieces. He moves a pawn, black moves a pawn. White's like, oh, I don't think I'm going to win this. Let's see if I can click this. Okay, so my coordinates must be off. Which I guess makes sense. Let's see. Oh, it's probably because I'm writing to winner. No, that's all I should have to do. If click coords is... oh, maybe it's because you need to have a or click coords equal to 9-8. Or click coords equal to 9-8. If this doesn't work, I promise I will do some more robust checking. All right, I'm going to do some more robust thinking about these coordinates here. So in the bottom right of the screen, and the screen is 900 high, that means the first 100 squares is 0, and the last 100 pixels is 8. So the y-coordinate would be 8. And then the width would be... yeah, 8 or 9. So actually what I'm going to do is just every time we click, I'm going to print the X coord and the Y coord, and that is going to tell me where I'm clicking so that hopefully I can figure out what I am doing wrong. So that's 8, 8, and that's 9, 8. Okay, what the heck? So click coords is equal to X coord, comma, Y coord. Oh, it's because I'm using the comparison operator. You guys probably figured that one out already. This needs to be one equal sign if you want to set something equal to something. Okay, so all right, it boots up. It's white's turn. White tries to forfeit, and now it says black won the game. Press enter to restart. If I do, that's great. Let's move some pieces around. Let's capture some pieces. Let's move all of the pieces all over the place. And now, oh, the king's in check. That's cool. All right, he did not get out of check. Oh, black won the game. All right, enter. So the restart looks pretty good. Alrighty, and let's say black's unhappy with it. They quit. Forfeit. White won the game. Press enter to restart. Okay, so I'm going to go ahead and get rid of that print X and Y coordinate. But you guys, thank you so much for watching this tutorial with me. Thank you for coding along. If you had any questions about anything you saw in this video, be sure to let me know about it in the comments of this video below. Consider checking out my Patreon link if you'd like to become a super subscriber of the channel. It really helps me grow, and it really helps me dedicate a lot of time and effort to my YouTube channel and making cool projects like this. Thank you guys so much for watching to the end. Be sure to let me know in the comments below what additional functionality you feel might be missing from this game, and maybe we can rev it together. All this code is on GitHub, so we can certainly build it out and add functionality. But this is a really great two-player chess game, so I hope you guys had fun building it. I had fun teaching it. Thank you for watching. Until next time, consider subscribing to the channel, leaving a like on the video, tell your friends about Lemaster Tech. Thank you so much for watching. See you next time. Bye.